Dear friends, I now move to cracking uncertainty with probability MCQ part 3 of module 4. This is part of test your knowledge in business statistics in the age of AI. Let me now proceed with each question. Question 7. Inventory management. A warehouse predicts a 70% probability of receiving shipments on time. If the probability of running out of stock without shipments is 50%, what is the probability of running out of stock? Fairly simple question to answer. Use the rules of probability. You are required to find out what is the probability of running out of stock. So let me flash the answer. Choice A, 0.15 is the correct answer. Now let's look at how this is 0.15. Probability of stock out equal to probability of no shipment into probability of stock out given no shipment. Since you predict 70% probability of receiving shipment, probability of no shipment is 30%. Probability of stock out given no shipment is 50%. So let's substitute. Probability of no shipment is 30%. Probability of stock out is therefore 0.3 into 0.5, because probability of stock out given no shipment is 50%. So 0.3 into 0.5, which is equal to 0.15. Therefore, choice A, 0.15 is the correct answer. Question 8. A case on using joint probability principle. A company finds that the probability of high sales is 0.4 and the probability of marketing spend is 0.5. If these events are independent, what is the probability of both happening? Apply the simultaneous occurrence of two events, joint probability. When they're independent, they'll be equal to product of the individual simple probability of events. So let's now look at the answer. Answer is 0.2, choice A. Probability of high sales and high marketing is equal to probability of high sales into probability of high marketing, because these two events are independent. So it's equal to 0.4 multiplied by 0.5, which is equal to 0.2, and hence choice A is the correct answer. Let's now move to question 9. Customer retention prediction. An e-commerce platform observes that 50% of its customers make a repeat purchase. Of these, 60% subscribe to a loyalty program. Additionally, 10% of customers who do not make repeat purchases also subscribe to the loyalty program. What is the probability that a randomly selected customer subscribe to the loyal program? So what you are wanted is probability of loyal given subscribe. So let's look at this problem and try to solve. Answer is 0.35. Using the law of total probability, it's equal to probability of subscribe is equal to probability of subscribe given repeat into probability of repeat plus probability of subscribe given no repeat into probability of no repeat. So probability of subscribe is therefore the sum of these two probabilities. Incidentally, probability of subscribe is also called the marginal probability of two events, which are conditionally based, and you simply substitute and add them, marginalizing. In other words, subscribe occurs with repeat as well as without repeat. So let's do this now. Probability of subscribe is therefore equal to probability of subscribe given repeat 0.6 into 0.5 multiplied by probability of repeat. So probability of repeat is 0.5. Probability of subscribe given repeat is 0.6. Multiply these two. The second one, probability of subscribe given no repeat into probability of no repeat. So if 50% repeat purchases, 50% of the customers do not repeat. And therefore, this second part is 10% multiplied by probability of no repeat, which is 0.5. So multiply these two. Subscribe given no repeat into probability of no repeat is therefore 0.1 into 0.5. Add these two, you get 0.3 plus 0.05, which is equal to 0.35. And therefore, the answer is 0.35. Choice B is the correct one. Very, very, very interesting problem. Let's now look at the last question in this module, MCQ Part 3. Question 10. Marketing campaign effectiveness. A marketing campaign targets two groups, loyal customers 40% and new customers 60%. The probability of a loyal customer responding is 70%, while the probability of a new customer responding is 30%. What is the probability that a randomly chosen respondent is a loyal customer? So you are required to find out probability of a loyal customer given response. So let us now apply Bayes' theorem. You are required to find out probability of loyal given response. Now this I can write this as probability of response given loyal. I'm inverting the probability into probability of loyal divided by probability of response. That is the denominator is probability of response. Why? Probability of loyal given response equal to probability of loyal and response divided by probability of response. Now, probability of loyal and response can be written as probability of response given loyal into probability of loyal. Now, probability of response given loyal is prior probability, whereas what we want is the posterior revised probability of loyal given response. So let's now first calculate probability of response. Probability of response is equal to probability of response given loyal into probability of loyal plus probability of response given new into probability of new. This is the marginal probability of response. Now let us substitute the values into the places. Let's see, probability of response equal to 0.7 into 0.4. This is 0.7. Loyal is 0.4. Probability of loyal. Response given loyal is 0.7. So this is the first one. The second one, probability of response given new into probability of new. Therefore, the new customers are 60 here. probability of new, but probability of response given new will be 0.3 into 0.6. Because the question says the new customer responding is 0.3. This is given here. Loyal customer responding is 0.7. New customer responding is 0.3. I substitute, I get 0.28 plus 0.18, which is 0.46. And this is the denominator. Now, what is the numerator? Probability of response given loyal into probability of loyal, which is equal to 0.7 into 0.4. That is the numerator. Denominator equal to 0.46. Therefore, probability of loyal given response is equal to 0.7 into 0.4 divided by 0.46. Upon simplification, approximately the answer is 0.61 to 2 decimal places, and hence answer is B. Choice B is the correct one. This is a little involved question that is intriguing, and that's the beauty of Bayes' theorem. With this, I have concluded module 4, cracking uncertainty with probability, which is module 4, and all the 3 parts I have concluded now. Therefore, we will move to the module 5 very soon. Thanks a lot.